Hello, I'm Braxton Vaughn, and today we're going to be taking a look at, and I'm going to be showing you guys just how I built this traditional Japanese Fuigo. Hope you guys stay tuned, and I hope you enjoy. Today we're going to be doing a little bit of a different project than what has been seen before on my channel. I did do one previous woodworking project, but that was quite a while ago, and I think this one's going to be a lot more interesting. So I hope you guys stay tuned throughout the entirety of this video, and let me know what you think in the comment section below. I'd be really interested to know. So today what I'm going to be doing is I'm going to be talking about and also building a traditional Japanese bellows, also known as a fuego. I'm sure I'm pronouncing that wrong, but I've heard a couple people call it that. What that basically does is that allows me to, whenever I'm forging or blacksmithing with charcoal or coal, either one, then you can control the amount of air that you're getting into it. An electric, what I've been using before is an electric, like a hair dryer or electric blower, and you really, unless you have like a variable speed blower or some fancy piece of technology like that, you really can't get the control that you need with an electric blower. Now, you can also do a hand crank blower, but those also cost a little bit of money. And I think that I found the sweet spot for the home DIY blower. So the Japanese have been using this for, or used this for thousands of years, I guess. And these are traditionally used in making Japanese swords, the katana. So I figured if it's good enough to make a katana, then it's good enough to make pretty much anything I'm going to need. Katanas are fairly large. They need quite a bit of heat to get to welding temperatures, since they do use a laminated steel. So what I'm going to be doing is I'm going to be taking this piece of plywood. I'm using in this video 1/2 inch plywood, and I do believe I can get everything I need out of just a 1/2 inch sheet. So an 8x4 sheet that I've cut it down in the middle. So I have two 4x4 pieces roughly. So I'm planning on getting everything I can, and I'm also going to cut right now into a little bit about the plans just before we jump in. Alright, so this is probably take 5, and the reason that is because I pressed record, did it 5 little sessions, got it perfect, got it in the editor, and then all of a sudden realized that it recorded none of what I was saying. So, alright, so let's try this again. So here's the SketchUp file, and basically I just wanted to tell you guys a few key features that you really want to pay attention to. I also wanted to tell you guys that you can get this in the description below, and I can't take all the credit for this. I got the plans that I used. I'll link you to the actual plans page for his as well. So I got an idea from a channel on YouTube, and I can't remember where I got it from. If I find it, I'll link them down below to the video, link you to the video. And basically what I got from that video is, other than these things are a lot more complicated than they first appear, that he added a piece of glass in the bottom to help reduce friction. So I think that was a really cool thing, so I added one to mine as well. Actually, I used plexiglass, but either one's going to work just fine. So, alright, also, these little stop blocks are absolutely crucial, so you don't push your piston head too far into your actual close valves, or your valves in the back. Not really that crucial, because the valves are also obviously on the outside, but you also have the string on this side, and that can affect, if you push it into that and it hits the string, that it's going to eventually untie it, or something's going to happen. So anyways, these push blocks, or these little stop blocks here, are really nice. Also, you can use those to secure the walls of your Fuigo a little bit better. Alright, another tip that I can give you guys is that build your box and then build the whole Fuigo pretty much. Don't put on this front face yet, and then build your piston. And that's going to save you guys a lot of trouble, because if you build it before, then either it's going to be too big, which would be ideal, or it is, well, it wouldn't be ideal, it'd be better than if it were too small. And if it's too small, then you're just going to have to cut another piece, because you don't want air getting around the piston head. That's just going to, you're just going to lose pressure, you're going to lose air that's coming out of the blower, and that's no good. That's, I mean, you haven't spent, basically 2 weekends working on this thing for it to just not be as efficient as it could for just taking another 5 minutes and cutting another piece of wood. So just do it like I say, and build the box, and then make sure your piston head fits perfect with the felt on. Of course, don't make it fit perfect without the felt, and then get the felt on and now it doesn't fit. Definitely do the felt afterwards. But I used felt. You could use a lot of different things. Just don't use something like cloth. it's just not going to give you that spongy seal that you need. Also, traditionally they used raccoon fur, which is actually really cool, and I definitely would have done that if I had access to like raccoon fur, but to seal the outside of the piston head. And if you guys want to try that thing, then I have a YouTube channel that you guys could actually go and check out. His channel name is SkillCult, and I just found his channel. I've been binge watching his channel, and definitely check out his channel. I'm gonna link him down in the description below. But he does a lot of tanning and of hides and like stuff that he's killed. And he's a really cool guy. Yeah, definitely check him out. He's going places. So, alright, so that's pretty much all I have to say about this, other than the fact that definitely check out these Sketchup files if you're making one for yourself. So I'm going to link those in the description below. But I've talked long enough. Let's get into building this thing. Alright guys, so I have you guys set up here. This is my nearly vintage Craftsman table saw that's been running for a good time now. It still works great. But basically what we're going to do is we're just going to start cutting this down. And I'm now going to be cutting the base of the Fuigo. So what I've done is I've gotten my piece of plywood here, my first piece, and I've marked it. I found the longest side. Now one is 1/4 inch bigger than the other just because the saw, when they were cutting it at the home improvement store, just I guess wasn't straight. But I have taken this and I've found the factory edge. So this one here and the other side of this board are factory edges. So I'm wanting to make sure that I run a factory edge along the rip fence of my table saw. Now I'm doing this with a table saw because I have used this before in this configuration and it gets pretty good results. Now if you don't have a table saw or you're not comfortable cutting a large piece of wood on a table saw like this, then you might actually try to find another person to help you, or you can just set up a couple sawhorses and or set it up on the tabletop and cut with a circular saw. So here is that plywood piece that we cut off of the first time. And what we're going to be doing now is just measuring out for the back panel. So let's get the tape measure out and do some quick measurements. Alright, so we need it to be 24 inches tall by 48 inches long. So 2 foot, 24 inches by 48 inches. So we're just cutting off this slight piece here. So measuring again, we are at 48 and a half in length. So this piece is actually the length we need. Double check. We're at 24 inches. We are even at 24 inches entirely. Ready for the cut. Let's cut it. That was cut number 2. Now what we have left from this board is just this one sheet. So we're getting down there. Man, this thing is going to be massive. This thing is going to blow some air, that's for sure. Alright, so now we're going to be cutting the 2 face plates of this board. This Fuigo, Japanese Bellows. And yeah, alright, I'm excited. This thing's going to be pretty cool. So we're going to bring that to the 11-inch mark. Yeah, just to get us roughed in. Grab the tape measure. I'm keeping up with this thing today. It's pretty good. Oh wow, yeah, pretty good. That's pretty close. I'm happy with that. That's dead on. All right. All right. So we got the rib fence set up. We got an 11-inch span here. So we have a new piece of board here that we are going to be cutting off here. So I'm gonna mark the board and then we're going to cut one 11-inch piece by 48 inches, and that will become the actual front and back of the Fuigo itself. So, and then when we get that 48-inch by 11-inch piece cut, we'll just rip that one in half, or cut that one in half, and we'll just be good. So, all right, let's cut that piece out. I just found a light, so hopefully this will be a little bit better quality now. So what I'm going to do now is I'm just going to cut this board in half. So we need two 48-inch pieces, or 24-inch pieces. We have one 48-inch piece here. So I'm going to remove my rip fence from the table saw. My cross cut. I do have a crosscut sled, but it's actually it'd probably work for this, but anyways. Okay. We're sliding good? Alright. Put some eye protection on and make this cut real quick. Glad I caught that. Let's switch to the crosscut sled. Didn't make a very clean cut, but oh well. We can clean that up with some sandpaper. Alright. Those two are exactly the same. Alright, so there's those two pieces right there. Alright guys, so I just got all of the boards cut out. Now what I'm going to do is I'm going to try to mock fit them up. Make sure that all my cuts are exact, make any adjustment cuts, and then what I'm going to be doing is I'm going to be cutting out some of the rest of the pieces. Now, I still have one very large piece of plywood left, and I still have this small 7-inch strip as well. So it does look like I'm going to be able to make it. So if not, I may have to go out and buy another half sheet or something like that to make this work. But I'm really hoping that this is going to get down to one sheet, and this will be a one-sheet project. It's going to be pretty good. So if you have already every other thing but the plywood, then this should only be like a less than $50 project and make a really, really awesome tool. So, all right, so I'm super stoked, and I'm ready to get this thing done so we can use it. Hello guys, so it's been another day. It's actually a couple days since I last worked on this project. I didn't really have the time to get done with it at the time, so and I also needed what I thought I needed, a couple new pieces of wood. But actually I ended up finding a piece of MDF. It's not ideal, but this being a prototype, I'm not really that worried about it. If this ends up working out well, you guys can decide whether or not you guys want to build this with better wood or not. Ideally, you'd probably want to use something like a hardwood, but plywood will probably work just fine. I don't see why it shouldn't. And if you want to use a better plywood like a Baltic birch or some kind of hardwood outer plywood, I'm just using what they call sandy plywood, and it just has a really nice feel, and also it's got a nice cheap price tag to it. So it's pretty cheap and it looks good, so that's why I'm using it. But I didn't have enough with one full sheet to get everything I needed. So what I'm going to end up having to do is use this piece of MDF that I had laying around for random projects. Actually, I believe I was going to make a joining sled for joining boards, you know, making a joiner on my table saw sled, but it's now going to be cannibalized for this project. So alright, so what we're going to be doing in this is we're going to be cutting one of the side pieces for the Fuigo itself, and it's got a little bit of a funny angle. So what I've done is I've set up my miter, this old, I guess is what it's called, a miter gauge. I suck with namings on anything, so if I say something wrong, just bear with me. You know what I'm talking about. This piece here that allows me to make angled cuts across the table saw. So basically what I've done is I've set this to the right angle, but how I did that was I use a little angle finder. This thing, if you guys don't have one, these are actually like 20 bucks, and they are a lifesaver for a lot of different woodworking projects. So $20, and it saves you a lot of headache, a lot of math. I determined that it was just slightly less than 65 degrees, but I'll give you that exact angle real quick so you guys can match it. If you don't have one of these jigs, then you can easily just follow mine. So actually it's just slightly above. So 65 degrees, 65.5 degrees is. So I just put this part up against the stop board, set that up against the blade, and then adjusted my angle of this piece. So there we go, 65.5 degrees, perfect. That cut is going to match up perfect with this cut. So all we have to do now is come in on the back side of this, mark this off. Now I'm going to be cutting this board down to be the front of that face, so it's going to fit flush up against this section. So I'm just going to cut the length, and then we'll rip it down to whatever length I need to be at. That, now we just need the top. So let's cut that out real quick. Let's just mock this up real quick. Alright. So just imagine this is our base. We got this board here. Here. We got it here. Go on. Sit. Gosh. Jeez. Whatever. Alright. Now we have this board now. This is our front. And it looks terrible. It looks bad. Not happy with the look, but it's going to be functional, that is for sure. Now you see how this fits? This line is, I mean, it's dead accurate. Now I'll pull the length off of my SketchUp file, so that way I'm not just kind of eyeballing all this and it ends up being off. So I'll pull that off the SketchUp file and we will see. But yeah, so and then I will also pull the length of the top that I need off the SketchUp file as well. So it also has an overhang too, so it's not really too critical that it be exactly right. But we do have a bit of an issue where we have to have an angle cut. So we're going to have to set the table saw up to cut an angle, and then we'll have to make that cut on an angle so that it's flush up against the wall. And I'll show you what I'm talking about whenever we are assembling this beast. Alright, so pulling some measurements from the SketchUp file, I just found out that the top will have to be cut down to be 5 1/4 inches, and we will have to make that angled cut, but the angle will be similar. We'll take that angle off of this, since when I was thinking about it, you actually, with this change of angle, our angle from the wall from 180 will be different. Now I'll show you what I'm talking about in a minute. Alright, that's that top board. I think I cut that right. Oh yeah, that's going to work just fine. I hope you can see this, but it does kind of hang off that 1/2 inch I was looking for. These are, hold up, these are actually 4.5 inches. Change of plans. This board is in fact going on the inside, unless I cut down 1/4 of an inch, or 1/2 inch, which is going to suck. So we're going to, of course, I guess I'm going to have to do that. Yeah. That's it exactly. Alright, so we just cut these new boards out. At some point it cut out and I have no idea. I mean, I have like a 10-minute timer on my HD. I don't know how to fix that on my camera. Well, I'm using my Samsung S7, so S7 Edge. So it gives me like a 10-minute timer, and if I go over 10 minutes per clip, it shuts it off. So I corrected this. Here is our old ones. Here is our new ones. So our old ones were 4.5 inches. These are 4 inches. So that mistake was fixed. And alright, so this piece was left purposefully a little bit long, a little bit wide. This is the top board, I believe. Yes, this one's the top. It should be 5 1/4. So this one was left a little bit longer than 5 1/4, just so I can cut that angle off. So that angle will be, instead of 90, we're off a little bit. I think we're off the difference between the 65. So it should be about a 25-degree difference. So we can put this on a 25-degree angle. Should, unless I'm just being dumb, should give me that angle to where this thing will sit at that angle, but also sit flush against the wall. So we want a flush, tight seam instead of a potential air leak, air gap. So. Now, if my math is correct, that should lay flat against these boards here. We should have, oh yeah, okay, cool. It's good. Alright, you'll see what I'm talking about when I assemble this thing, but that was, in fact, I believe the last cut. I believe it was. Could be wrong. Well, I sure have made a mess. Let's fix that. You know, I've always wanted to do that. The magic of YouTube. Man. I mean, seriously, just snap your fingers and the workspace just clears. That's amazing. I wonder what happens if you do it again. Okay. Alright, so that's what happens if you do it twice. Do not do it twice. Alright. Alright, let's get back to the video. There's a dowel. Actually just picked that up. Broom handle might actually work as well. I'm just not sure about the fit. So broom handle would work. Just anything that you can match to a hole that you can create. So this one happens to be 1 1/8. That side piece, the piston head of this. So this is the same board as we used as the side. or the side piece, and I believe it'll work. We'll see. If not, I'll make one or something. But that's good for a prototype. I just took a chalk line, found the corners, popped it, found the exact center. I'll measure and make sure, but that's good enough for now. Alright, so from what I remember, the flaps will be on this side. What I want is as clean of a finish on this side to give me the best seal possible. We'll clean it up with sandpaper, but since I can't get to that interior very well, it's best if I just go ahead and just punch holes straight through, and whatever mess on the other side I'll just have to clean up with sandpaper as best I can. But so I'm not too worried about it, to be honest. This is Fuigo piston 1.0. This is the first design. Well, technically it'd be 0.5. And I just put a single screw through the exact middle. I used a chalk line on each corner, found the exact center of the MDF, and then found the center of the dowel and drilled 2 dead straight holes through both of them, and then just screwed it through. The screw came a little loose. I should have used a smaller bit, but anyways, the screw I think will hold, and it's got a liberal amount of glue down in the hole for the screw and also around the dowel, so hopefully it'll draw to the MDF. Alright, so this is the point I'm at on the Fuigo as of right now. I have the 2 holes for the vent, so those are the one-way vent valves, air valves. You can see I've had some issues drilling holes, but this will be covered up anyways, so not a real big deal. Drilling up through plywood is incredibly difficult. I also cut the valve plates. These have a really fine finish. I finished them to 800 grit just to give them a nice flat and soft finish, so I feel like that will give me a better grip. That's not necessary, I guess. 220 grit would probably be just fine. I'll also finish this to 800 grit as well. Okay, so I cut these out. These are 2 inches from the bottom plate and 3 inches from the face, or from the edge of the face. So, and then cut a 3x3 square hole for each. These plates are cut to 4 inches by 4 inches, just to cover the area pretty good. And to keep the weight down, you don't want them to be too big. So also to help with weight, I've sliced off the edge. So this is how they will sit. They'll sit just like that. And then when they are strung, they will sit flat, and then the air will pull them out. And then when you pull back on the piston, it should seal. So that's that. I've got 2 of those cut out. I need 2 more. So I'll show you guys how I do that in a little while when I'm cutting those. But as of right now, I'm going to work on cutting the holes in the front and the back plates. Take 653. So what I've done here is I just marked out 4 and then 3 1/4 down, or 2 1/4 down, 2 3/4 down, and 4 from each side. Marked out a 3x3 square, and that's where my valve will go. sheet of plexiglass for a smooth surface. Yeah, that should slide really nice. I think traditionally they either use glass or they just negated this whole step. But I'm going to do sandpaper on the walls to get me a nice clean fit. And we're going to put some kind of felt or some kind of fabric on the piston. So it should slide really nice and easy now.